I'd like to share with you my experience of putting together a RISC-V build with a new piece of exciting hardware that's out this year. It's my first time trying to put together a video on YouTube, really, and it's been as much or more of an adventure just trying to learn tools to put this simple video together as it has been learning the ins and outs of this new architecture. I don't have time to get into all of the details, and I'll link to some videos below where others go into great depth and explain much better than I ever could about ISAs and architectures. But if you want to think super simplistically about it, then Intel x86 like Intel and AMD are an architecture. ARM is the platform that powers most of our phones. That's an architecture. Open Power is another, and RISC-V is somewhat of a new kid on the block, even though it's been around a while and there have been smaller boards and I think mostly IoT devices. Now we're starting to see boards that can be full-fledged PCs, development environments with running Linux. And it's a board like that that we'll be looking at today, basing the PC build around. I'll point you to the RISC-V International site for more information about the ISA and how it's open. I'm really excited about that aspect with the company HiFive manufacturing actual boards and systems on a chip that won't have secret management engines from Intel or AMD embedded. And I say secret, it's more opaque and risky vectors for exploits. So similar to the promise of the open power systems, you're looking at something that is open and auditable and a step back towards actually owning the devices that you have on your desk. I really didn't know much about this until close to the end of last year, and still don't know a lot, but here's the board from HiFive, the Unmatched, that caught my eye. Instead of a small IoT device, this is really ready to be a full-fledged PC. Instead of small embedded operating system or just headless server, you start looking at the supported architectures from a desktop version of Linux, and you can see that, as I mentioned earlier, you've got Open Power, ARM, Intel and 64-bit, AMD 64, PowerPC, even old Spark is still on the list, but we don't see RISC-V in that list yet. If we get over to Debian, then we can see that RISC-V, the 64-bit, is listed there. And of course, Ubuntu is Debian-based. Now, unfortunately, we see it claims to be unofficial, but if we switch back to Ubuntu and search enough, we can find that they have indeed put together a 2104 image for not just RISC-V 64 in general, but specific to this board. So people with early versions have done some incredible work, it appears, in getting it ready for this HiFive Unmatched system. Turning back to the board, you can see that HiFive sells through Mouser or Crowd Supply. I had never ordered through Crowd Supply, so I chose Mouser. Turned out to be a little faster shipping since I'm in the eastern US. You can see at the time of this video they're showing about a 30-day lead time on things, and I would say it was many months from the time I ordered until I received the board, but that was in the midst of all those component shortages that were causing manufacturing issues for everybody. So just what do you get with this hardware? You can see they have a system on a chip with their 64-bit quad-core RISC-V processor. 16 gigabytes of memory. During the manufacturing process and the delays, they were able to update that from 8 to 16, which was great. Micro SD card, as you'd expect for storage. Ethernet port, which is great. I don't intend to use Wi-Fi, so happy to see that. USB-A ports, and then the expansion capabilities are great. That a couple of M2 slots, so you can take advantage of a NVMe drive. Again, the Wi-Fi I'm not going to be concerned with, and the PCIe slot for graphics cards, all in a nice Mini-ITX form factor. So finally we get to the good stuff. Let's talk about components. Of course, the Unmatched is the board itself. Documentation in the HiFive manuals mentions a range of SSDs and some graphics cards which they have tested that should be compatible. For storage, I chose a Samsung 500 gigabyte 970 EVO Plus. Figured 500 gigabytes would be plenty of space. Definitely don't intend to long-term run things off of the SD card. Now, my graphics card selection was mainly a function of what was expedient, in that it was laying around from old dusty systems that I had. HiFive mentioned other AMD cards, not this one in particular, but again, since I already had it and I've seen it mentioned at least once in other cards in the family on Reddit posts about where people were talking about the Unmatched, that I'm pretty hopeful I won't have any trouble with it. The chief goal is just providing some sort of display out because there's no integrated graphics on the board. I'm not looking for a lot of graphics oomph, and this older board should definitely be sufficient as long as it plays well with drivers. I'll be using my 4-port KVM, which is DVI, so even if I used HDMI out, it would get cut off for as far as the audio signal when it comes to the actual displays. Plus, I'm just going to 2 Dell monitors, which don't have any kind of speakers. But that leads to the next component, which is a little Creative Labs Sound Blaster USB dongle. If we look at the board, not just a lack of integrated graphics, but actually there's no sound out. And with me not being able to leverage the sound through the HDMI, I needed another device. This got good reviews on Amazon. It actually only claims compatibility with Windows and Mac, but the reviews were favorable by people using it on Ubuntu. For the case, I chose a little Cooler Master Elite 130 Mini-ITX. Once again, looking on Reddit posts on RISC-V where people were discussing the Unmatched, I saw this suggested there, and it looked nice, so I thought I would grab one myself. And it turns out it's a good roomy case to build in, as we'll see later. I went completely overboard on the power supply as far as wattage, for sure, at 650, but I could use it later if it gets repurposed in another build. And I definitely wanted a quality supply with a good rating, since the Unmatched is not a cheap board. Here's a shot of everything except for the little audio dongle before I began assembly. The power supply attaches to a back plate which slides in, and with it removed you can see there is a lot of room to work with mounting the board. The case comes with 2 chassis fans, and we'll talk about those later. Here you see I've got the motherboard back plate inserted, as well as the standoff mounting screws. I want to note that these are the little brass standoffs that came with the case so that it fits the board to the height for the back plate. The Unmatched itself does come with some standoffs, but they were much too tall for this. Here was a test fit on the back plate before I actually screwed down the board, and here you can see the board finally affixed. I've also gone ahead and mounted the SSD, and you can see the empty M.2 slot where the Wi-Fi would go if you were going to use that. Another thing to note is the empty button battery slot in the top right of the board there. You see apparently there's an issue with a real-time clock, so even if you had a battery in there, the date and time would be reset. But with connecting to a network, that takes care of setting the clock, so I've not seen a problem with it. If and when they get the driver fixed or whatever the issue is with the clock, then probably go back in and add a battery in there. Here you can see the power supply being slotted back in from the rear of the case. It rests over the board, and that chassis fan you see in the back left is actually got a rail above it that supports the power supply there as well. Definitely modular was a good option. With the power connected, you can see the cords are still a little busy. Part of that crowding in this case is you see at the right of the picture the front audio and USB headers there that really have no place to go because there's no connectors on the Unmatched for those. There are small wires you can't see there that go to the front power, reset, and LEDs, and those do have connectors on the board. And the last piece of the puzzle was to put that Radeon graphics card in and get ready to fire it up. Now I would suggest you familiarize yourself with the LEDs in the manual before you boot for the first time, which I of course did not. Now I was aware that using the graphics card instead of connecting over console or serial through micro USB, I was going to miss a lot of early boot messages, and even if everything went perfect, it was going to take a little while in the boot sequence before I would see anything come across the display. So when I was a little too impatient and looked in and saw the one light that was not green, I naturally assumed something was wrong, shut down, and then finally read the manual. Here's another picture from a boot sequence where I was patient and noticed the other LED light that's on the other side of the onboard power and reset switches. You can see it barely through the cables there. And after that, finally the sweet evidence of success on the screen there. Now I forgot to mention another reason that I thought there was a problem with that one purple LED was that I had no power to either of the chassis fans. Now the fan that is mounted to the processor was running fine, but in the end, after looking at the HiFive forums and seeing other people talk about issues, I simply went to Molex connectors and got another modular cable for the power supply. And even though there's no speed adjustments for the chassis fans, powering them directly off of the PSU has worked fine so far. As I mentioned before, the modular power supplies really help cut down on the cable crowding, but as you can see, cable management is kind of a mess. Fortunately, that extra Molex connector just sits on top in a drive tray that's not being used with the system. Now, since my goal here is to use this as a workstation for development, I knew I wanted to run those Ubuntu 2104 images if at all possible. So I went back to the HiFive manuals that I mentioned earlier and looked at the information they provided on booting from SD, or ultimately the goal was to get it running off the NVMe drive. Then I found some direct instructions for working with that Ubuntu image from this great blog that explains how to prepare a card with Ubuntu, and I used a blank SD card that I had which met the criteria listed in the HiFive manuals for the board, and then I gave it a try. Everything worked fine, and following other instructions in the blog, I looked further on to just make sure that the NVMe drive was coming up okay and just appearing in the system as a device and that I could mount it. Following the blog instructions, I just could not get it to boot off the NVMe drive. So I looked a little further and found on the Ubuntu discourse someone had gotten permission to take that blog and expand on it a little bit with details about how until maybe some firmware is fixed, that the SD card will be required for the initial stages of boot. And there were some steps to take to make sure that you didn't have a race condition when you were trying to use the SD card for those first parts of the boot, and then hand things over to get the kernel and other parts of the boot from the NVMe drive. So I looked in my config file and found that the root entry that they instructed to change was pointing, as you see, was cloud image root fs. So then I followed the guide and went over to the U-boot configuration and changed root to point to the NVMe drive. Then you update U-boot at that point, which modifies the config file. One thing I'd forgotten to mention earlier was that I had followed the blog instructions and had taken that Ubuntu 2104 image and not only written it to the SD card, but I had put that image as well onto the NVMe drive to prepare it. And after that last U-boot update, it was fantastic to see success, and the boot messages showed that it was now booting from the NVMe drive. Now that I was booting from the SSD, it was time to go back to the discourse and set up a desktop environment. So following that guide of packages, I set up basic Gnome. After restarting, it was great to see the graphical login. Guess I should have mentioned earlier, there is a rough edge with shutdown or restart, so you can issue a shutdown command in Linux, and once everything is good and kosher, you wind up having to use the physical power button or the reset button on the machine. And there we see the system properties show we are running an AMD graphics card, CR 500 gigabyte NVMe, and the default host name is Ubuntu on the images, 64-bit OS. And you see a little rough edge there. It does not pick up the specifics of the processor information. This is filmed a little out of sequence, which will make sense later, but after seeing that graphics card info and the system properties, I went on a hunt to look at the stats of the card and try to determine what driver it was using. There was talk about the older Radeon drivers versus new AMD GPU open source drivers. And I'm still not been able to get to the bottom of that, so I'll be looking for help on the forums and seeing what I can find in the coming days. But Bonaire class card, I set about just trying to make sure that it should be able to run the newer drivers, assuming I can find the right ones that are compatible with the architecture. So after that, I went to install a browser, and following the blog instructions, they suggested Epiphany, and that seemed like a good idea. So when I went to do that, I found out that the Epiphany package that they mention is a slight typo, where it's actually a game, it's a Boulder Dash clone. So in order to get the right package, you want Epiphany-browser. Again, things are a little out of order because I had to get the screencast program on to be able to capture and record from the Unmatched. So here I'd already installed Epiphany, but we can watch as it tries to load a web page with no acceleration. Pretty rough. You never know how much you rely on Chromium and V8 until you don't have it. Or at least you think about how bloated modern web pages are. And finally, the saga of recording the screen. I looked around and tried to find what I thought would be some of the most simple recording packages that were likely to be available on RISC-V already. And Simple Screen Recorder looked like it would fit the bill. I forgot to actually check and see if it was in the package repository to begin with, but I ended up adding the PPA per the instructions to get to the latest version. And after installing that, I thought things would be good. Before I tried it, I knew I would need something to play back videos that I recorded, so of course I looked for VLC first, which was in the repository. But it turns out that VLC has locked up on me for who knows what reasons. So I found that MPV was in the repository and installed that, and it's been working like a champ. When I went to playback videos, even in MPV, I noticed that the first captures that I had made were blank. And it was only after looking into it further that I realized 2104 was defaulting to Wayland and Simple Screen Recorder, and basically every other available screen recording app seems to want Xorg as well. So here we see on the login, choosing Xorg, that solved all the problems, and as you see, I've been capturing video. So if you found yourself watching this rough first take all the way to the end, I hope there was something of use in here to you. I believe the next steps, if I decide to make more videos, will be to document customizing things and getting all the tool chains set up. I'm not a low-level systems programmer, so my goal here is to explore things like Rust and Mono and trying to get Node to run, and maybe even help contribute to getting Visual Studio Code running or .NET Core over here, although the latter would be challenging. But there's got to be some baby steps that I can start with here on just getting some of the foundational pieces in place so that I have a chance of being in a position to contribute. It's very exciting to see what's available in the repositories. I can't imagine all the hard work that's gone into things so far. I see, Elixir, Erlang, Rust, OpenJDK, Python, some Mono packages. So now that I can record from the HiFive, I hope to explore some of that next. So thanks, and maybe we'll see you again.